Imagine it's early morning. You're stretching, making coffee in the kitchen. While frying eggs, you turn on the TV out of boredom. A running line appears on the screen.
Breaking news. A new unknown object has sliced off a part of the sun. Remain calm until we confirm all of the details.
You bolt to the window, lift the blinds with one hand, and hold your breath for a second. Phew! So far, so good. The room is illuminated by a bright light. But for how long? Could the planet survive if a piece or even half of the sun got sliced off? Get ready. Today, a fantastic experiment awaits you. To get started, let's fast forward to the sun. To understand the situation, we need to consider how everything works inside of our star. The sun is a huge flaming ball of gas and plasma made up of several different layers. Of course, the world hasn't yet invented a material from which we could forge the most heat-resistant space knife. After all, the average temperature of the sun's atmosphere reaches 2 million degrees Celsius. That's 3.6 million Fahrenheit. And inside its core, it's 7 times hotter. Even the most fireproof material to date, which is an alloy of tantalum hafnium carbide, would melt at 3,990 degrees Celsius. That's 7,214 Fahrenheit. But let's imagine there's a giant space knife made of the latest material, able to withstand any temperature and density of matter. It would be delivered to the sun by an autopilot spaceship because it's too hot for a human to travel there. And let's all agree right away that we all understand perfectly well that in reality, it would be impossible to cut off a part of the sun. As I said earlier, the surface of the sun is not a solid substance, but a turbulent, boiling plasma. But we have an experiment here, right? Therefore, the sun in our video will be cut into pieces like a watermelon. If the inside of the sun were empty, we'd need about 1 million planets like ours to fill it. But inside our star, there's already a filling, a mixture of hydrogen, helium, and literally a pinch of other elements. However, while we've been chatting, a huge space knife has already cut off the top of our star. Now there's no reason to panic. Only the outer layer of our luminary was disturbed, the chromosphere. Of course, the sun still has a hellishly hot corona and a transition region. But there's nothing that could be cut there. The density of this matter is so low that it's almost comparable to a vacuum. So, let's get right into it. Given the size of the sun, the piece we sliced off is just over 2,000 kilometers, or about 1,200 miles thick, and its surface area is 9 billion square kilometers. That's about 3.5 billion square miles, which is difficult to imagine. The surface of the chromosphere can't be called smooth. It's all dotted with luminous columns of plasma, like spikes. If you simply cut the sun and moved a piece of it into space, our star would instantly pull it back. The gravity of the sun is so strong that it would do so with ease, as it would be with any part of the star, which is extremely important to maintaining the shape of the sphere. But let's imagine that this piece simply disappeared into space. What would happen? Most likely nothing fatal. The mass of the sun would still be large enough to continue fulfilling its function. The main variable here would be if this cut-off piece of the sun moved towards the Earth. When approaching our planet, it could be destroyed by the pressure of the Earth's atmosphere, and a vacuum would form in its place. An explosion would occur, and a shockwave would cover the planet. It would break windows and tear apart our eardrums. In general, not great prospects. Now, let's make an effort and cut off exactly 1/4 of the sun. Here, all layers of our star would be affected. Our knife would go through the chromosphere, hook on the layer below, the photosphere, then additional layers, and of course, reach the solid core. Thanos snaps his fingers and a quarter of the sun disappears in space. Imagine that in the most dangerous vessel in the universe, where the pressure is 265 billion bar, there's now a hole. And now a huge amount of hydrogen and helium, heated to gigantic temperatures, together with gamma radiation, bursts from its bowels. There are no more layers restraining, absorbing, and distributing this mad energy. How would this threaten the Earth? Unprecedented gamma radiation. This has a very high penetrating ability, but while passing through the Earth's atmosphere, it would partially dissipate. In the event that the solar core was exposed, the strongest gamma-ray burst, a large-scale cosmic emission of explosive energy and incredible brightness, would fall upon our planet. Our atmosphere could still withstand the pulse wave, but gamma rays would begin breaking the bonds between nitrogen and oxygen molecules in the atmosphere. As a result, we'd be awaiting supercooling, abnormal rains from nitric acid, and solar radiation. In fact, the sun we now know would cease to exist. This would be the birth of a new star. And at the stage of birth, a star's character can be quite unpredictable. It's unlikely that the usual order of the solar system would be preserved. After all, the sun is 99.8% of the total mass of the entire solar system, and suddenly this number would decrease by a quarter. Most likely, the Earth would no longer be able to rotate as before around the sun. The brightness of our star would drop 25%. So the Earth would no longer be in the habitable zone of the sun. It would begin cooling until all rivers and oceans froze. Within a few years, the Earth's surface would turn into an icy desert, like on Europa, Jupiter's moon. If humanity could survive, it would only be in some underground bunkers. The simplest forms of life would be preserved only in hydrothermal waters. And in any case, if a small piece of the solar core somehow reached Earth, then there would be no trace of an ice crust left. Just imagine, in order to destroy all life within a radius of several tens of kilometers, a substance literally the size of a pinhead would be enough. So what do you think would happen if a quarter of the entire solar core reached the Earth? As you might have guessed, when the sun loses half of its mass, the changes would have an even more deadly effect. It's unlikely that humanity would have months to adapt to new conditions. If we weren't immediately killed by the strongest gamma-ray burst, then natural disasters, a magnitude of which Earth has never encountered before, would do so. But if somehow lucky survivors remained on the planet, then they would inevitably die shortly after anyway. Earth would be thrown out of the solar system through the vast expanses of space. Without a protective sun, it would become a target for asteroids, meteorites, and other planets. It's hard to imagine such a multi-layered killer scenario, even in the most exciting blockbusters. Perhaps the sun is best left alone. However, if you think the idea of controlling stellar matter is something only my imagination could come up with, then I must upset you. Scientists have long been looking at stars with the goal of stellar farming. It'll be important for future generations, and perhaps even our direct descendants, to control the evolution and properties of a star, including increasing its lifespan, extracting materials, or even creating new stars. But not for the sake of mere curiosity. For example, in order to increase the lifetime of a star, it's necessary to slow down the nuclear fusion taking place in its core. So you would need to rid it of excess mass. Stars already lose a small flow of mass via solar wind, coronal mass ejections, and other processes. A method called star lifting would have to increase the natural plasma flow so that it could then be manipulated using magnetic fields. The idea is excellent, but it's scary to imagine what the consequences might be if we try intervening in the ways of the universe. To minimize risk, we'll need something to hone our skills on. For example, an artificial sun. Such a simulator is already operating in the United States, and one will soon appear in China. This sun can be fearlessly blown up, cut, reduced, and enlarged. And only after we know in advance all the possible consequences and understand the risks would we move to the next level, working with a real object. In the meantime, let's let everything be, and let these experiments merely remain as figments of our imagination. So, what do you think about manipulating stellar matter? Let us know in the comments, and don't forget to like and subscribe to our channel. We still have a lot of ideas and experiments ahead.